Hey guys, I hope you're doing great today. This is our chapter number 24 in which we are going to start with CICD. Guys, let me tell you one thing that CICD is the backbone of DevOps. Go to your LinkedIn profile, go to your LinkedIn account and search for DevOps jobs, and I am pretty sure that you will find CICD as the main requirement for every DevOps job. So it is a must learning tool that you must know about CICD and the CICD tools like Jenkins, GitHub Actions, Travis CI, GitLab CI, and so on. So I repeat that CICD is the backbone of DevOps. And that's why, guys, we have created the base for CICD. We now know that how we can work and execute commands in a Linux terminal. After that, we covered Docker because Docker plays a crucial role in CI/CD. And after that, we covered the basics of Git and GitHub because we are going to build our code that is hosted on Git. So I'm pretty sure that you are now getting the learning path of DevOps roadmap. This is our DevOps roadmap 2024 in which we have covered Linux, we have covered Docker, Git, and now CI/CD. So today's lecture is actually an introduction to CI/CD. What is the difference between CI and CD? And also we will discuss a couple of benefits of CI/CD. So make sure, guys, you subscribe DevOps Molvi on YouTube. We are going to cover a lot of stuff regarding CI/CD in this series. So let's get started. Alright guys, CI/CD is actually divided into two sections. CI is different and CD is different. CI stands for continuous integration and CD stands for continuous deployment or continuous delivery. So there are actually two terms and there is a slight difference between deployment and delivery. So CI stands for continuous integration and CD can be continuous deployment or it can be continuous delivery, and we will definitely discuss the slight difference between each of these terms. There is a minor difference between deployment and delivery. So there is a slight and you can say a mini difference between deployment and delivery, but the core purpose is the same: to deploy software. For the deployment of software, CD tools are used. Now let's discuss what is continuous integration and what is continuous deployment. So there are both different terms and we must know the difference between integration and deployment. So first, continuous integration. So if I am asked to define what is continuous integration, so the simplest definition of continuous integration is a software development strategy that improves both the speed and the code deployment. We know that developers are working on a single software project and they make tons of commits in a single day. So there can be multiple developers and each developer is working on a software project and each developer is making some commits. You know what is a commit, right? We have discussed it in our Git section. And at the same time, each developer wants to know that whether his or her code is working properly and there are no bugs in that code. So we must have a tool that automatically builds and tests the code, ensuring that everything is smooth and fine. And that process is known as continuous integration. So let me repeat it again. So there are developers, each developer is working on the same project and they are writing the code, they are committing the code, and at the same time that code is automatically built to ensure that this new code works with the existing code base, and in case of any issues we can simply roll back the deployment, and in the meantime the developer is notified about the errors and he fixes them, so the code is deployed again. So it is a never ending chain. Our code is always being built and tested and deployed, and that is why it is known as continuous integration. The code is being updated, it is always being built, and it is being tested and deployed. Now let me explain continuous integration with a simple diagram. For instance, we have a team of developers and I am working as a DevOps engineer with that development team. So what are developers doing? They are actually writing the code. This is developer who is writing the code, and he is making some comments. We write the code, developers write the code, and they commit. Where they comment on Git or any version control software, and let's suppose we have Git, and this is my version control, and our code is hosted on GitHub. Okay, so developer writing the code, he or she is committing the code, and that code is actually, this is our code base where all the repositories and our code is hosted, or we have the repositories on our Git version control. And after that, this Git is actually linked with our CICD tool. Now for instance, we have this tool known as Jenkins. We are going to install and build our pipelines on Jenkins. So Jenkins actually automatically fetches all the changes, okay, and after that this Jenkins tool does two important steps in continuous integration. It builds the code is built, and that code is tested at the same time. Okay, now again, developer is writing the code and he is making the commits. That commits are in the version control Git. Okay, after that, when there is certain change in the code, our Jenkins server automatically fetches the changes. That is actually, there is option known as SCM poll, by the way. Now we will definitely see it in our Jenkins lecture. So SCM poll, when we enable it, Jenkins actually fetches the automatic changes, and those changes are built and tested. Now there are actually two steps here. For instance, if the code is built and tested and the result can be the code is passed, for instance there are no issues and there was error-free integration, there were no errors in the build and test phase, then this code is passed and it is further moved to other steps of deployment. Okay, deploy. So we have this code as passed and it is ready to be deployed. But in case this code is failed, there are chances that the code is failed because there are tens of commits on a daily basis, and maybe not every commit, not every change in the code works perfectly. So in case it fails, then we must notify at the same time to the developer that, man, that code is failed. You have to check the code and then make some comments, make the changes again, so that we can build and test the code again. So guys, you can see that it is actually a never ending loop. Okay, this chain never finishes. That is why it is continuous. Developers are writing the code, they are committing to Git, and we have fresh and new code every time. Jenkins is aware of the changes and it automatically fetches the changes and builds the code, tests the code. Test means unit test, regression test, integration test, and after the code is passed, there are no errors, there are no failures. That code is ready to be deployed on our dev, on our staging, or even prod environment. And if it is failed, it is not deployed, because we do not deploy the code with errors. So at the same time, developer is notified, and that's how continuous integration works. And by the way, Jenkins is open source and free continuous integration and continuous deployment server. So we will install and we will work with Jenkins, and we will see how we can build and test the code. So that is actually continuous integration. This is CI. So we have covered the first part in our CICD introduction, that how CI works, how continuous integration works. And guys, in addition to that, continuous integration goes hand in hand with agile methodologies. And what do we mean by agile methodology? It is an approach to perfectly manage our software development project, because in agile methodology we have to keep in mind about the flexibility, collaboration, and responsiveness to the customer needs. And that's where continuous integration plays an integral part, because continuous integration supports all these frameworks by encouraging smaller but more frequent code changes for the better testing and delivery. So we can say that the basic idea behind continuous integration is quite simple, which is to commit and integrate your code quite often or on a daily basis. And these small commits or small changes in our code base can result in bigger changes. So there are a number of advantages of CI, continuous integration. Improved team productivity and efficiency. We can get better product by modifying our code, and that matches with the customer needs. We can have higher quality, more stable code on our version control system. And that's how we can increase the customer satisfaction. And DevOps engineers play a crucial and important role to make the developers happier and more productive. Alright guys, now let's talk about the second part. We have covered CI and now CD. Continuous deployment or continuous delivery. First of all, we should know the difference between deployment and delivery. There is no manual intervention required. Okay, no manual intervention or human intervention, we can also say human intervention, is required to build and deploy the code. Whereas in continuous delivery, we require a little bit manual intervention. So guys, if you are asked about what is the difference between continuous deployment and continuous delivery, the purpose of both terms is the same: to deploy the code. You saw that in continuous integration we have built and tested the code. Now we are going to deploy that code to our deployment environment. So there are two approaches. One is continuous deployment, the other is continuous delivery. The purpose is same, to deploy the code, but in deployment it is fully automated because there is no manual intervention is required, so it is fully automated. Whereas it is not fully automated, we can say somehow, because we need some manual intervention to deploy the code. So continuous deployment is fully automated without any intervention, and in continuous delivery we need some manual intervention to deploy our code. That is actually the key difference. Otherwise the concept is same, to deploy our code. So if I want to differentiate between both terms, we can do it as this is our continuous integration, and once the code is built and tested, there are actually two terms. One is delivery, this is manual, and this is automatic. automatic. Okay, now this is actually delivery, so it is manual, and this is deployment, and it is automatic. There is no intervention, and both are used to deploy the code to our prod environment. This is our prod. Okay, so we have code built and tested from our CI tool. Then this code is whether automatically deployed via using automatic deployment or after some manual intervention. So it is code CD. So it is continuous delivery, and this is continuous deployment. The purpose is same, to deploy our code to prod, staging, or dev environments. I hope that now you understand it better. So now if I complete the CI/CD process, here is my developer. Okay, developer. He or she is writing the code. The code is committed 5 or 10 times a day, and that code is in our version control software like Git, which is our code base. This is our code base, and that code is automatically detected, or the changes are fetched by our CI continuous integration tool like Jenkins, and that code is actually built and tested, built and tested. Okay, the changes here are detected or fed by our continuous integration or continuous deployment server, which is Jenkins. And after that, if the code is passed, then it is deployed to our dev or QA or prod environments. And in case the tests are failed, the developer is notified again about the changes that have been failed, and that developer works again. So you can see that CI/CD practices are worked together. Okay, you can see this is actually a full software development life cycle. Now we can say it is a software development in which we are developing, in which we are delivering, deploying the software, and it is a never ending chain, never ending loop in which the code is continuously built, tested, and deployed. Where CI actually focuses on the changes in the code. Okay, CI is focused on changes in the code, and CD is focused on deploying the code. CD is focused on deploying the code, whereas CI is focused on getting the changes in the code. And together they make a CI/CD pipeline. We are going to discuss in detail about the full CI/CD pipeline. So that was actually an overview of CI/CD. So CI/CD as continuous integration and continuous deployment work together to monitor the changes in the code, testing that code, and deploying the same code for rapid and speedy software releases. So this collaborative approach actually speeds up the development life cycle, and it improves the code quality and ensures a consistent customer experience. So your customers are happy when they're getting the code and releases with their features, with their required features on time. When we are using CI/CD practices to develop, build, test, and deploy our code, we can get a lot of benefits like faster release cycles, improved code quality, error-free code, reduced risk of code failures and deployment failures, and increased collaboration between the developers, software engineers, and DevOps engineers. Because guys, the purpose is to make our customers happy, and our customers would be happy when they get their required features, required code successfully built, tested, and deployed to their respective environments. So we can say that CI/CD brings the developers and customers together. So we have a team of developers and software engineers who are working on a software, and that software is continuously tested and released as per the expectations of our customers' needs. So we can say that CI/CD plays an important role, and it combines and collaborate among the developers, and the customers want the features, developers build that features, and CI/CD helps us to quickly build those features and test it, so it makes the developers productive and our customers happy. Alright guys, that's it for today's lecture. In the next and coming lecture, we are going to talk about a CI/CD pipeline. I mean, what are the steps in a single CI/CD pipeline? And we will also discuss about some of the popular CI/CD tools like Jenkins, Travis CI, CircleCI, GitHub Actions, GitLab CI, Argo CD, and so on. These are all DevOps. These are all CI/CD tools, and we will have a quick and overview of each tool. So the next lecture would be more exciting, where we are going to discuss how CI/CD works, what are the steps in a single CI/CD pipeline. So make sure that you subscribe my channel DevOps Molvi on YouTube. I will watch you in the next lecture. Hey guys, I hope you're doing great today. This is our chapter number 25, in which we are going to discuss about CI/CD pipeline. Guys, in the previous chapter, we discussed about what is CI/CD. CI/CD stands for continuous integration and continuous deployment, or continuous delivery. We also discussed the major steps involved in CI and CD. CI is focused on code building and testing, while CD or code deployment is focused on the code deployment or code delivery. We also discussed the slight difference between code deployment and code delivery. Code deployment is fully automatic, whereas code delivery involves a slight human intervention to deploy the code. Now, you must be thinking that what are the steps involved in a CI/CD pipeline, and in this lecture we are going to discuss all those steps that make a great CI/CD pipeline. So guys, if you have not watched my previous CI/CD lecture, make sure to watch it, because you have to clear your CI/CD concept to better understand the CI/CD pipeline. And also, I would request you to please make sure that you have subscribed DevOps Molvi on YouTube. I need your support. So what is a CI/CD pipeline, and what are the steps involved in a CI/CD pipeline? Let's discuss them one by one in this lecture. So guys, there are a couple of steps that are involved in a CI/CD pipeline, and CI/CD pipeline is a never-ending loop. You must have seen this logo or this image whenever we talk about CI/CD pipeline, because the pipeline consists of certain number of stages that are executed one by one, and it is actually a never-ending loop. So let's start with our stage number 1, or we can say that this is our first step of a CI/CD pipeline, which can be called as code commit or code checkout. So that would be our first step in a CI/CD pipeline, and I would say that it is code commit or code checkout. Okay, normally they are considered as a same step: code checkout or commit. The best pipelines are automatically triggered when there are new commits or new pushes inside the code. Whenever developer is writing the code, and when he or she commits the code, the pipeline should automatically trigger. So the code is actually checked out, and we have that code on our GitHub or GitLab code bases. So code is checked out in this step, and this actually involves a webhook. Okay, a webhook. And We discussed webhook in our Git tutorials, Git lectures. A webhook actually notifies or triggers. A webhook actually is the reason which triggers the pipeline. Webhook is clever, it is intelligent, and it notifies or pushes the pipeline that there has been some changes and we got a new code. The developer has committed the code, now it must be checked out, and webhook actually triggers the first stage of a CI/CD pipeline. Now our code is being checked out, okay, and now our pipeline is aware of the new changes in the code. So that is actually the first step in which code is committed, code is checked out. Okay, I would write it as checkout, code checkout. Now after that, guys, we have the second major steps of code build. Okay, code build, or I can say it code compile. There are different number of people use different terms like code compile. It can be code compilation, it can be code build, but normally it is the second step in which the code is built, the code is compiled, the code is packaged into the dependencies. And after the compilation completes, after the build completes, we get a binary, we get an artifact. So I would subdivide it into 3 more steps so that you never forget what are those steps. The first is code compilation. Okay, my code is compiled, like we run npm install manually and it compiles the code of node. We run mvn clean install and it compiles the maven or java code. So code compile actually compiles the code, and the packages or dependencies are packaging the dependencies. Okay, dependencies. So the dependencies are packaged, code is compiled, and we get the final form of artifact. So this is just like a jar. Okay, we get the jar file when we run a maven code, when we compile maven code, apache maven. Code is compiled, dependencies are packaged, and an artifact, it is executable. Okay, you don't get confused with what is an artifact. It is just a binary, an executable. Okay, and it can be a jar file like in our maven or java code. The artifact is created into a jar file. So an artifact or binary is an executable that is actually at the final step we containerize it so it runs on the deployment server. So these are actually 3 important subtasks that run under the umbrella of code build, which is our second stage of our CI/CD pipeline. Sorry, I forgot to run CI/CD pipeline steps. Okay, I'm sorry. So that is actually our second stage, and it is successfully completed. Code is compiled, dependencies are packaged, we get an artifact, we get a binary, and after that, the third stage, our pipeline moves to the third stage. And what is that third stage? It is actually code testing. Code testing. This is build. Code is checked out, code is built, and now code is tested. Code test. So we have been on our third step, check out, build, test. Now what does we mean by code testing? and it is also subdivided into, I can say that, unit test, unit tests, and integration test. Integration test. Guys, these steps are actually generic. The other companies or software houses can have their own steps, okay, like end-to-end integration steps or regression tests. So I would just mention the major that are commonly practiced in CI/CD pipelines, and those are unit tests and integration tests. Guys, we run now. There is a difference between unit tests and integration tests. We run unit tests to actually identify any issues with the code itself. Okay, now we have checked out the code, we got new code, so we built the code. Now we need to check whether this code is fine, it does not contain any issues. So we run unit tests, and by the way, these unit tests are also automatic and they run automatically inside the pipeline. And guys, there are actually a number of tools that are available for unit testing, like code coverage, JUnit, PHP unit, and so on. So these tools are actually integrated inside the pipeline, so to make sure that our code does not contain any issues. So finally, we can say that unit test checks the code for errors. There are any errors inside the code, and if the test pass, we move towards our second test, which is integration test. Now, what do we mean by integration test? It is actually the components check. Let me explain it. Components check. So guys, there can be a lot of services or integrations and components inside a pipeline, and integration tests run to check those services and those components are working well together. So depending upon the pipeline, there can be a lot of services, components inside that code. So we need to make sure that all those services, all those components, modules work well together and there are no issues. So we run integration test for testing the components or modules. We run unit test to check the code for any errors. I hope that now you are clear with code testing stage inside a pipeline. And if all the tests are passed, okay, now we assume that our tests are passed, unit tests and integration tests are clear, we will move towards the fourth stage of our CI/CD pipeline, in which our code is packaged. Okay, now this is our fourth stage and it is about packaging. Guys, we saw that we have this artifact created, and after that this artifact and code was thoroughly tested and we had unit test and integration test. All the tests were good, passed, and we have now to package our code into a binary or a Docker image. So I will make it more simple. The code is packaged and now we will create a Docker image of that code. So here our Docker build command would be used. Okay, Docker build, and we will have a Docker image of our code, and when we have this image we can deploy it anywhere in the world. And now further, we have our own written Docker files. Now I hope that you know a lot about Docker. We wrote a Docker file, we built the Docker images in our Docker section. So Docker file is used to build the Docker images, and when we have those Docker images we can deploy them on our AWS or Google Cloud or any other cloud environment. So that is actually the fourth stage or fourth step of CI/CD pipeline, in which our code is packaged into a Docker image. Alright guys, the final step of our CI/CD pipeline is to deploy our a Docker image into a container and run our Docker image into a container. So this would be our fifth step of CI/CD pipeline, in which deployment, okay, code deployment. So we have this Docker image. So this would be our last step of our CI/CD pipeline, and it is code deploy. And now, in order to better understand the code deployment, let me subdivide it into three parts, or three mini stages of code deployment. The first stage is the registry, okay, image registry. Guys, I hope that you must know about Docker Hub and Elastic Container Registry, Azure Container Registry, image registry, which contain the fresh version or the updated version of our Docker images. Each time the pipeline runs, we get a new image pushed to our image registry. So we have this new image to be deployed on our deployment server or on our cloud environment. So image registry contains the updated releases, the updated version of the images. Each time the pipeline run, we will get a new Docker image, okay, and this Docker image is stored into our image registry like Docker Hub, like ECR, or Google Container Registry. After that, we have to authenticate with our deployment environment. If we are going to deploy on the cloud, definitely we have to authenticate. Or if we have a deployment server or a VM, we will SSH authenticate with this server. So once we have the updated version of our Docker image in our image registry, we will authenticate with our deployment environment or deployment server. It can be a VM or our cloud environment. Then we can pull the updated version of the Docker image and we can run it into a Docker container. The last step of our pipeline, in which we are going to run the container, okay, and it is actually Docker. So we will have a running Docker container as our last step of our CI/CD pipeline. So my apologies, it seems to be a little messed up, but let me repeat the whole steps of CI/CD pipeline again so that you can better understand. We have this first step in which we check out the code. The developer is writing the code and he or she is committing the code. So every time we get a new code, and our CI/CD tool like Jenkins or GitHub Actions actually use a webhook, and webhook actually triggers the pipeline. This webhook actually notifies the pipeline that there is something going on with the code. The code has been updated. So code is updated, or code commit, or code checked out. Our code is then checked out. So, and this step is done by our CI/CD tool. So code is checked out, then the code is built, okay, in our second stage of the CI/CD pipeline, in which we compile the code. Like I told you that npm install or mvn clean install, these commands at the back end, these commands are running and our code is compiled. All the dependencies are packaged so that we have a final artifact or binary, or like I shared the example of a jar.jar file. If we are talking about Java code, so we have this artifact or binary, and this code build stage is completed, and after that we have to test whether our code is error free, there are no errors inside the code, and that's why we run unit tests and we run integration tests. Unit tests actually are automatically executed to check for the errors or issues in the code, and integration tests are also run to check whether all the modules or the components are working fine together, they are well communicated or well bound together, and after that our tests are passed. If our tests are good, and then we move towards the next phase or next stage of our CI/CD pipeline, in which our code is packaged into a Docker image. Okay, now we had the binary and we run tests. The tests are passed, and I told you that those test those tools, there are a number of tools to perform unit testing, like p unit, php unit, j unit, code coverage, etc. And then our Docker image is built so that we can deploy this Docker image onto our cloud environment, cloud deployment environment, or it can be a VM, a virtual machine, the deployment server. So after that, our CI/CD pipeline enters into the last phase or last stage. And guys, this is all automatic. There is no manual intervention involved to execute all these steps. After that, in our fifth deployment step, we have three subtasks. Actually, if I combine all these subtasks, then it can be 11 or 12 steps in this CI/CD pipeline. But to better and simplify it, I have divided into subtasks, in which in the code deployment we have this image registry, which contains the updated version or releases or tags of the images, Docker images. And then we authenticate in this step with our cloud environment, or it can be our VM, so that we can deploy our Docker image. And the final step is to run the Docker run command, so that we can run our Docker image into a Docker container. So when we have this Docker container running, it means that our application has been deployed into a container. So my fellas, if you are asked about the CI/CD pipeline steps in generic, you must know these five major steps that are observed in every pipeline. And after that, those pipelines can be modified as per the organization needs. But these are actually the five generic, we can say these are the general CI/CD pipeline test, in which code commit or code checkout, code build, code test, code package, and code deploy. You must know these five major steps of a CI/CD pipeline. And you saw that I have subdivided, and we created sub tasks of each of these steps of CI/CD pipeline. Now I hope that you understand what is a CI/CD pipeline, what are the stages of a CI/CD pipeline, and how CI/CD pipeline works. So you and I hope that now you are aware of all these terms, like compilation, packaging, dependencies, artifacts, unit testing, integration testing, Docker build, packaging our artifact into a Docker image, and deploying this Docker image into a container. This pipeline is focused on automatic deployment. This is actually fully automatic. If we have code delivery instead of code deployment, now we must address this code delivery and code deployment difference here as well. So we can say that in code delivery, this step is not automatic. We have to deploy our artifact, we have to deploy our Docker image manually on our, for instance, if it is a production server and I don't want to be deployed automatically, then this approach is used, which is known as continuous delivery, in which we ourselves involve our intervention to deploy the code onto our production server. There is some manual intervention required, then it becomes continuous delivery. And if it is fully automatic, then it becomes continuous deployment. So this pipeline actually focuses on continuous deployment, in which from writing the code to deploying the code. All the steps are automatic. Build, test, and packaging, everything is fully automatic. And every time this pipeline runs, we have a fresh container which contains the recent changes of the code that developer made inside the code. So guys, these are the 5 major steps of a CI/CD pipeline, and all these steps are subdivided. So you must and I hope that now you have a clear picture of a CI/CD pipeline, and you know what are the steps of a CI/CD pipeline. And still, if you have any confusion, you can ask me in the comment section. And actually, we are going to practically perform all these steps when we are going to write our pipeline ourselves using the CICD tool like Jenkins or GitHub Actions. So we will observe, we will practically check how each CICD pipeline step is executed. So something more exciting is coming on the way, and that's why I would really appreciate if you subscribe DevOps Molvi on YouTube, so you can be on the same track with along with me, and we have our CICD chapters covered as quick as possible. So if you have any question, please make sure to ask, and I hope that you have a clear picture of CICD pipeline. I have tried my best to cover, to elaborate, to explain the pipeline into more simple and more generic steps. For any question, make sure to ask them. I will watch you in our next lecture. Hey guys, I hope you're doing great today. Well, this is a short tutorial about CI/CD tools that are required for our infrastructure automation. Guys, in the previous 2 lectures, we discussed about continuous integration and continuous deployment. We know that now continuous integration is focused on code testing and code building, while code continuous deployment or continuous delivery is focused on code deployment. We also discussed the difference between continuous deployment versus continuous delivery. Now we know that continuous deployment is fully automatic, while a little manual intervention is required in continuous delivery to deploy the code on our deployment environment. Now this would be a little short and quick tutorial about the CI/CD tools that you must know as a DevOps engineer, because we know that CI/CD is the backbone of DevOps. But I have gone through the list, and guys, there are over 20 plus CI/CD tools. But I have shortlisted, and the most frequently used CI/CD tools are 10, the top 10, and we will discuss those 10 CI/CD tools in this lecture, and we will have a quick look on their features. So let's get started. So first of all, we should know what are the CI/CD tools. So CI/CD tools are essential components in software development, right? Without CI/CD tools, we cannot speed up our software development process, and it helps, the CI/CD tools help automate the process of integrating and delivering code or deploying code, right? So continuous integration, CI, ensures that code changes from multiple developers are regularly merged into a shared repository where they are automatically tested to detect and address any issues. Guys, that is actually CI, continuous integration. And as we have already discussed in our previous lectures, CI is highly focused on building and testing the code. Okay, CI plays an important and crucial role to build and to test the code, and if there are any issues, the developer is notified accordingly. So that is actually continuous integration. Now, what is continuous deployment? Continuous deployment or delivery takes this step further by automating the release of code to production environments. After all, we have built the code and we have tested it. There were no issues in the code. Now it's time to deploy the release or the final version or the artifact to the cloud environments or to the deployment VMs, and we have to ensure that new features and fixes can be delivered to users quickly and reliably. So that is actually the difference between CI/CD, and these CI/CD tools streamline the entire development pipeline, reduce manual errors, enhance collaboration, and ultimately lead to faster and more efficient software delivery. So guys, that was a little overview of CI/CD tools. CI/CD tools help us to automate that process from building the code, from writing the code to releasing and deploying the code. Now, there is actually that is some important point that I would like to highlight here, that integration with version control systems. What does that mean? It means that if you are a GitHub user, then you should use GitHub Actions, because if your project is hosted on GitHub, GitHub Actions offers seamless integration, making it a convenient choice. And this is actually most of the times our code, like we also discussed in our previous lectures, our code can be hosted on GitHub. It can be hosted on GitLab or Bitbucket. So these are the three cloud version control systems where we host our code on the cloud. So if you are a GitHub user, then you should use GitHub Actions for your code building, testing, and deployment, for your CI/CD pipeline. And if you are having your code on GitLab, so it is recommended for GitLab users to use GitLab CI/CD for more integrated options, offering native CI/CD pipelines. And similarly for Bitbucket users, Bitbucket pipelines offer integrated CI/CD capabilities within the Bitbucket environment. So if you're, that is actually a recommendation. You can say it is a recommendation that if you are hosting your code on GitHub, you must use GitHub Actions for your CI/CD pipeline. And if you are using GitLab for your code, then you must use GitLab CI/CD. And if you are using Bitbucket for your code, then you must use Bitbucket pipelines, because that would be more easy, integration would be more easy, and it would make more convenient to build and deploy the code, because we are having all the same environment from writing the code to deploying the code. Okay, so that was actually a recommendation. Now let's start with our 10 best CI/CD tools for our infrastructure automation. And what are those tools? Number one is Jenkins, GitHub Actions, GitLab CI, CircleCI, Azure DevOps, AWS Code Pipeline, Travis CI, Bitbucket Pipelines, CodeFresh, and Bamboo. Now let's talk about these tools one by one and quickly have a look on their features. So number one is Jenkins. I hope that you have heard its name. Jenkins is an open source automation server widely used for continuous integration and continuous delivery. Okay, it has a vast plugin ecosystem. It means that over 1,000 plugins, we have over 1,000 plugins to support building, deploying, and automating projects. And it is one of the easiest job to install any plugin. You just have to search for the plugin on your Jenkins, and you just need to click the install button, and that plugin is installed. And we have over 1,000 plugins to play with, to work with on Jenkins. And it supports a wide variety of version control systems. It means that Git, Subversion, SVN, and Mercurials, these version controls are supported by Jenkins, and it is highly customizable pipeline scripts. We can write Jenkins file to write our CI/CD pipelines. So without any doubt, we can say that Since Jenkins is open source, it is free forever. It is the most loved and most frequently used CI/CD tools among all the CI/CD tools available in the market because it's free, it's open source, and it has a huge plugin base where we can install about 1,000 plugins of our choice to build and automate CI/CD pipelines. Number two, GitHub Actions. It is a GitHub's native CI/CD tool enabling automation directly in GitHub repositories. You have your code on GitHub, you create the repository, you write the code and push that code to the repository. Then after that, if you want to build and deploy that code, you can write the CI/CD pipeline within that repository's environment to build, test, and deploy code. And GitHub Actions is a fantastic CI/CD tool with a lot of features like deep integration with GitHub repositories, supports custom workflows with YAML, and extensive marketplace for pre-built actions. What does that mean? If you are having your application in Node or React or Java, we have predefined, pre-built workflows, YAML files already configured and running on our GitHub account that we can use and modify and customize according to our application requirements. So GitHub Actions is the second most frequently used, and I would recommend that as a DevOps engineer, we must know how to write and how to run CI/CD pipelines using GitHub Actions. But don't worry, we will have a complete tutorial on GitHub Actions. Number third, GitLab CI/CD. GitLab CI/CD is integrated into GitLab just like we have GitHub Actions on GitHub. We have GitLab CI/CD if our code is on GitLab, and it also provides robust tools for continuous integration, delivery, and deployment. And the features are the built-in CI/CD pipelines with GitLab repositories, auto DevOps for automated CI/CD pipelines, and the third most important feature is Kubernetes integration for container orchestration. So these are actually the features of GitLab CI/CD, and it is the third most important and lovable CI/CD tool. Number four, CircleCI. Guys, I'm also sharing the logos here. You can see this is actually the logo of CircleCI, and each tool, just like we have this for GitLab CI/CD, and this is for GitHub Actions, and this man is for Jenkins. So I'm also sharing the logos so that you must know this tool is CircleCI. And CircleCI is a cloud-based CI/CD tool that automates the build, test, and deploy processes. It provides integrations into multiple tools and can be configured to run complex CI/CD pipelines. And there are also features like it can be integrated with GitHub and Bitbucket, and Docker support for containerized environments is also available in CircleCI, and auto scaling to handle large workloads. So CircleCI is also one of the best CI/CD tools we have for our infrastructure automation. Number five, Azure DevOps, and it is a set of development tools from Microsoft Azure that includes CI/CD, version control, and project management. If you have your infrastructure hosted on Azure, you have VMs, you have network, you have applications running on Azure, so that is also recommended to use Azure DevOps for CI/CD pipelines. And guys, by the way, Azure also provides Azure repositories where you can host your code, and from there you can build and test and deploy your code using Azure DevOps tools. And they are also integrated with Azure Cloud Services pipelines for CI/CD with support for multiple languages and platforms, and built-in testing and deployment tools all over on a single Azure platform. So instead, if you are having your infrastructure on Azure and that I'm not saying that it is not possible, but it makes more convenient to use the native tools, the home tools of that cloud provider. For instance, if your repositories are hosted on Azure, then you must use the CI/CD tools for your code using Azure DevOps. So it reduces the complexity, by the way. It reduces the problems, it reduces the errors handling. So you don't have to invest, you don't have to integrate your repositories, your environment with other cloud-based environments. So make sure that if it to make your code build and testing more convenient, you must use the native tools of that cloud provider. Similarly, we have Cloud Run. If you have your code, your repositories, your infrastructure on Google Cloud Platform, and that is number 6, which is AWS Code Pipeline. If you are hosting and you have your applications, your infrastructure on AWS, then you must use AWS Code Pipeline because it automates the build, test, and deploy phases of your release. And also, each time if the code change occurs, AWS Code Pipeline automatically builds and tests and deploys your code inside your AWS environment, like AWS container service, Kubernetes service, where you want to deploy. So you have the whole cloud environment and you can use all the native applications of that cloud environment. So AWS Code Pipelines allows you to integrate third-party developer tools like GitHub or Jenkins. We can integrate it and we can use in any of stage of our release processes with one click. And also Amazon AWS Code Pipeline can pull source code for your pipeline directly from Amazon Code Commit. Okay, AWS ECR or AWS S3 single storage bucket, or if we have our code on Code Commit or Elastic Container Registry, we have container images on ECR, then it makes more convenient to use Code Pipeline to build, test, and deploy the code. So that is actually a feature offered by AWS. If you have code on Code Commit, we can use Code Pipeline for CI/CD. Travis CI, number 7. Travis CI is an integration, continuous integration service which is easy to set up and integrates well with GitHub. Travis CI is great in the continuous integration of out of the box solutions. So there are a number of features in Travis CI, which is travis.yaml file to write your CI/CD pipelines, and it supports multiple programming languages, and we have both cloud and on-premises option for our CI/CD pipelines. So guys, this is also mandatory to know how we can write YAML. GitHub Actions CICD uses YAML. Okay, and the rest of the tools like GitLab CI/CD also uses YAML. CircleCI also uses YAML. So that is the most important part that if you remember, we discussed while writing the docker compose.yaml file. And I told you on that day that you have to run YAML files. You have to make sure that you know how we can write a YAML file, because in DevOps, YAML plays a really important role. CI/CD pipelines and also like Kubernetes infrastructure deployment, they are also using the YAML file. So you have to make sure that you must know the configuration of a YAML file. Number 8, Bitbucket pipelines. And it is also a CI/CD tool which is integrated into Bitbucket if you are having your code on Bitbucket, and it also provides a continuous delivery pipeline with your Bitbucket repository. So just like GitHub, just like we have GitLab CI/CD, if our code is on Bitbucket, we can use Bitbucket pipelines to build and deploy our code. So it is I said it is also YAML based pipeline configuration, and it has built-in Docker support, and it is integrated with Jira for issue tracking because it is provided by Atlassian, so it has the Jira support and integration as well. Code Fresh number 9, which is our second last DevOps tool for CICD. It is Code Fresh, which is Kubernetes native CICD platforms. Why I have shortlisted? Because Kubernetes also plays a really important role in our DevOps journey, in our DevOps tools. So we know that we must know a single tool, CICD tool, which is specially designed for Kubernetes deployments, and it is CodeFresh, and it also focuses on containers and microservices, providing robust tools for modern applications. And the CodeFresh has a number of features in which the top three are listed here. Kubernetes native with built-in Docker support, visual pipeline editor, and GitOps based deployments using Argo CD. So CodeFresh is specially for Kubernetes CI/CD pipelines and Kubernetes deployment. And the last CI/CD tool for our today's lecture is Bamboo, and it is also Atlassian CI/CD tool designed for continuous integration, deployment, and delivery. And also, it is integrated with CI/CD with Atlassian tools like Jira and Bitbucket. So we have the option to use either Bitbucket pipelines or Bamboo, and they'll work like a charm, guys. They're really user-friendly tools for CI/CD, and we can have parallel builds and deployments. And there are actually extensive plugin support for customization using Bamboo. So, guys, these are actually the top 10 CI/CD tools for our infrastructure automation. Now, there should be a question in your mind, and it becomes overwhelming that should I learn all of these CI/CD tools? And the answer is no, because it becomes a little overwhelming to know all of these CI/CD tools. And I would like to quote an example of Linux distributions. I would ask you guys that if you can work on Ubuntu, there are over 500 Linux distributions like Fedora, Red Hat, and Cloud Linux, Kali Linux, Ubuntu, and CentOS. But if you can work on a single Linux distribution, it means that you can have your hands on all the rest of the Linux distributions. Am I right? So that's the same case here. If you know one or two CI/CD tools, you can be able to work on the rest of the 10 or 20 CI/CD tools. So make sure that you at least know two or three of these CI/CD tools. And don't worry, we will taste a few of these CI/CD tools. And just like I have shared the example of Linux distribution, if you know Ubuntu, you can definitely work on Debian or Red Hat Linux. So if you know Jenkins, if you know GitHub Actions, you would be able to write CI/CD pipelines on GitLab CI/CD or CircleCI or Bitbucket pipelines. So that's it for today's lecture. We will be going to work on our GitHub Actions CI/CD pipelines in the next lecture. Make sure that you support my YouTube channel by subscribing DevOps Molvi on YouTube. I will watch you in the next lecture. Have a good one. Take care, and thank you so much for your support. Hey guys, I hope you're doing great today. This is our CI/CD practical session in which we are going to talk about how GitHub Actions work and how we can configure a CI/CD pipeline. Guys, I have also created this repository on GitHub. You can find it in the description. I will share its link. And we are building this repository together, and I will be creating branches. Like you can see, this is my main branch and Docker and Git. And I will also include the CI/CD nodes here. So just like if I want to see Docker, we have Docker commands and how we can install Docker in the Docker branch. So similarly, I have it a git, you can see now there are around 52 docker commands here. So these are actually the branches, respective branches, and where we are going to build our nodes. You can see we are going to save our nodes, like in the git branch. You can see in our git branch, I have also created a couple of nodes, so you can find everything on this single repository. The idea is to have everything that is required in our DevOps roadmap 2024, and we have this on our this repository. Now I have also shared the git commands here as well. So now as soon as our uh, journey proceeds, I will be adding nodes on this central repository, which is DevOps Molvi YouTube. And guys, I have also mentioned the link of my channel, DevOps Molvi. So make sure that you subscribe it. Today we are going to discuss about CICD on GitHub Actions. We already have covered what is CICD, what is CI, continuous integration, what is CD, continuous deployment or continuous delivery. So we have covered all the basics. We have covered the basics, concepts of CI/CD and how a CI/CD pipeline works. Now there are a couple of tools like Jenkins, GitLab CI/CD, and GitHub Actions CI/CD. So a couple of friends asked me that we should start with GitHub Actions CI/CD. We can cover Jenkins later. So that's why I have created these two repositories so that we can discuss how CI/CD works on GitHub Actions. We will see the syntax. We will see how we can write a YAML file in CI/CD on GitHub Actions. So GitHub Actions is also a free tool, CICD free tool, which offers you a couple of features that are available for free. And there is actually a cap of minutes, how long you can run CICD minutes, how long you can run their free hosted runners on GitHub Actions. So everything we are going to discuss in this lecture. So make sure that you watch this full video to have your GitHub Actions concepts cleared. By the way, there must be a question in your mind that why GitHub Actions is called as GitHub Actions. Because my fellas, GitHub Actions pipelines they actually contain the code snippets that are known as actions. Now, for instance, let me create our first repository. That would be a test repository, and we are going to create a CI/CD pipeline, or we are going to create our first workflow from scratch. Now this is GitHub Actions tutorial. Like, I will say it as tutorial, and now I will keep it as private. And now we can, okay, for now we will keep it public so that you can see what we have done in the repository. Add a readme file, and I will just create a public repository on GitHub, and we will create a simple Docker file as well in this repository. Okay, we have this, and I will edit it as GitHub Actions CICD tutorial. We can edit any file from here. Clicking on this pencil. So I will just add it as our GitHub Actions CICD tutorial and practical lab session. So I will just commit in the main branch. So I will create a new Docker file here, and I will just have one instruction from busybox. Okay, busybox, and now I will commit the changes. This is my Docker file. Now this is actually the CI/CD of GitHub Actions. You can see that get started with GitHub Actions, and you will be able to see a lot of templates. We can see these are the deployment templates of like we can build and deploy to Google Kubernetes engine, deploy to Amazon Elastic Container Service, Azure Web App. So whatever you configure, you will have a predefined template of the CI/CD pipeline. And now it is also saying that you can skip this and set up a workflow yourself. And if you want to have like we have the Docker file, so it has suggested as this workflow, or we can use this workflow as well. And Docker image, build a Docker image to deploy, run, or push to a registry. So let me continue with this workflow. Now you can see I have predefined some of the CI/CD pipeline. So it is actually only CI, continuous integration. You can see Docker image continuous integration, and this pipeline will only build the Docker image with the current date. Okay, now what is the syntax? We need to understand the YAML file of GitHub Actions. This is actually, you can see the Docker image YAML, and I can rename this YAML file to myself. And there can be multiple YAML files, multiple workflows in a single repository. So now the name is Docker image continuous integration, and let me change it, my Docker image CI. And on push branches main, pull request branches main. Now what does this mean? It means that when there is certain change in the code, this is just like a webhook. It is a trigger that whenever there is a pull request and when it is approved, this pipeline should automatically trigger. Or when there is any change in the main branch, any file, any update in the main branch, then this pipeline should automatically trigger. We can use workflow dispatch, like workflow dispatch, and you can see workflow dispatch, it is for the manual. If you want that my pipeline should not automatically trigger, then you can use workflow dispatch and you can trigger your pipeline manually. That's what we use workflow dispatch, manually running a workflow. Okay, so for now we are making it automatic, and then if there is any push in the branch, then this pipeline would automatically trigger. Now there are actually jobs, and the first job is to build. And what are we going to build? We are going to build a Docker file, Docker image with the help of Docker build command. And this build will actually run on Ubuntu latest. This is our GitHub Actions runner. We are not using any self-hosted runner. We will create a self-hosted runner, but now we need to understand the difference between a GitHub Actions runner. We will get a GitLab CI agent, Azure agent in Azure DevOps, and self-hosted runner on GitHub Actions. This is actually the GitHub Actions runner. These are GitHub runner. And now this build, the whole build job, there is actually one build job at the moment, and it will use this action. Now that is why GitHub Actions is known as GitHub Actions, because we have a couple of actions like checkout, like Docker login. Now if I search for this action, there would be a full repository. Now you can see GitHub Actions while I was working for the first time on GitHub CICD, there was actually the version 2 and version 3. Now it is version 4 of checkout actions. It checks out the whole repository. It checks out the contents, the files, the code of a GitHub repository. That is why this action is known as checkout. Now, let's explore a little bit more. What is checkout used for? Now you can see this is a full repository, and this is actually a GitHub action. That is why GitHub Actions is known as GitHub Actions, because it contains a couple of actions combined together in a CI/CD pipeline. You can see used by 10.3 million people, and how many contributors. There are a lot of contributors, and this GitHub action is used in millions of repositories on GitHub. And now this action checks out your repository. Okay, this action checks out your repository under GitHub underscore workspace. Now this workspace is actually created on the GitHub Actions runner. Guys, these are important concepts that you must know while you begin with GitHub Actions CI/CD, so that your workflow can access it, overbuild the artifact, the compiled code, everything would be saved in GitHub workspace. And that workspace is this action uses our repository. It checks our repository, and everything is saved in GitHub workspace. Only a single commit is fetched by default, and for the reference that trigger the workflow. So when we have a commit in our repository, then this action will be triggered and it will go through our repository. Now you can see everything is discussed here in detail, how we can use it. This is the use case. Now similarly we are using here in the same manner, and now there are more features and more use cases of this GitHub action. Like we can check, we can study it in more detail, and there are a lot of use cases and scenarios of this checkout action. So that's how we will use this GitHub action. And what will it do? It will build the Docker image. And how the Docker image would be built, that's why we created our own first Docker file with image busybox, and this would tag my image name, and I can change the my image name as DevOps Molvi images, and the date and time of today's, and this would be the tag. Actually, that is actually the tag, and current date and time would be the tag of our Docker image. So guys, this is actually the basic syntax of the YAML file. Now we can add more use cases. We can add more jobs in this pipeline. Like for instance, I will add a new, just to see name of the release of the GitHub Actions runner. What is the release and OS? I would like to find uname -a. For instance, if I want to run multiple commands in this single step, now this is actually the step, okay, and I can use this pipe symbol, and I can run multiple commands here, cat etc issue, and that's how I can create touch abc.txt. So we can execute our bash scripts or Python scripts as well within this pipeline. Now, for instance, if I want to know the Docker images or in this pipeline, within this pipeline, I can copy this one, and I will, this is YAML, so we have to make sure that our syntax is correct, and Docker images. Now it will also, for instance, if I want to see if there are any containers running, then I can run this pipe symbol, and I can run multiple commands like docker ps -a and so on. So that's how we can run multiple steps and in the same build, which is using our GitHub Actions runner. And that's how we can use our first checkout GitHub action. And first of all, it will build the Docker image. This would be the image tag, and the Docker file is here. This is the Docker file we have in our repository, the release or operating system of our GitHub Actions runner, and it will run these a few commands in this step, and then we can find the Docker images on our GitHub Actions runner. So I will now save, and I will commit it. Then this pipeline would automatically trigger, and our GitHub Actions runner Ubuntu latest would be used. And let's commit the changes here, and this would be new file that would be created in the main branch. Now I will open the actions here. You will see that one workflow is automatically triggered. Okay, so you can see that our build has been completed and everything has run smoothly. So these are actually the steps of our CI/CD pipeline. In the first step, now we can see each step one by one, and you can see this is our current runner version. Okay, and the runner's operating system, which is Ubuntu 22.04 LTS, the runner image Ubuntu 22.04, and the version, and also we can see the included software in this image. Okay, now we can have the GitHub token permissions here, and we can see these are all read permissions of this token. And now download action repository. Okay, we have already saw this actions repository, sorry, this one. And now this action repository has checked out our code and everything, and this job has been completed, which was the build job. Okay, now after that, run actions checkout version 4. Okay, now this action would actually run, and it will scan, it will go through the repository, and all these are the parts, or you can see the requirements of this action, and it has synced the repository, and we have this workspace here. Okay, now you can see this is the working directory. We would have this on our GitHub Actions runner. We don't have access to this runner because these are all managed by GitHub, and this is actually the workspace where our build, our code would be compiled, and this is actually the workspace. Okay, and then after that, this workspace would be used further for our code deployment as well. And now after that, you can see our build would be completed in the build Docker image job. Now these are all jobs. When one job is successfully completed, then our CI/CD pipeline moves to the next job. Here we can see the job was to build a BusyBox image with this tag. You can see the command here as well. That was the command, and the command was executed successfully, and you can see the image the base image busy box with latest tag was pulled, and that's how our image has been built using the Docker file. And after that, we saw, now you can see this is the image, okay, docker.io. This is the full tag of the image, and you can see this is the time and date of that image, okay. And after that, we have run a couple of commands and we can see their outputs. This is the actually the output of uname minus a with the Linux architecture of our operating system. This is the release of our operating system. And now here we can see the other images on this runner. Not only we have our image, but there are also other images on this runner. So we can use the Docker images to find other images. Now here is our image, which is DevOps Molvi images, and this is actually the tag. And guys, by the way, you can run one moment, we can run this tag here and Google will show us in Linux in bash. What is that in bash? And you can see in this command uses the s format string to display the current Unix time, okay. Now this is the time and date, so we have this in our, this is actually the time of our current runner, so that would become our tag, the image tag. Now we can see no output of Docker PS. There is no container running on this runner, GitHub Actions runner. And after that, the job is cleaned up and our job has been completed with all the successful messages and everything is cleaned. So that's how, guys, we can run a simple CICD pipeline. That was actually a CI pipeline in which we have built a simple Docker image. All right, so let me repeat. Now you can see this is a success. When our pipeline is successfully completed, then we can see the success tick mark on each pipeline, and now we can see the workflows. Now we have to know more about GitHub Actions runner, okay. Now in settings, there is option of GitHub Actions runner, and here you can see the runners, and there are no runners configured. What does this mean? We have not created our own self-hosted runner. Our pipeline is using the GitHub Actions runner, which is Ubuntu latest, and that is actually the most common runner that most of the pipelines use this GitHub Actions runner. Now there should be a question in your mind that whether we have other GitHub Actions runner or just we are limited to only Ubuntu latest. So I have searched about that and we have other GitHub Actions runner as well. GitHub Actions runner, let us Google it, and we have other GitHub hosted runners, and these GitHub offers hosted virtual machines to run workflows. So we saw practically we used our GitHub Actions runner and we executed a couple of jobs using this runner, and this contains an environment of tools, packages and settings available for GitHub Actions to use. You saw that we didn't have to install Docker. Our Docker commands were running without any issues. So these questions must arise in your minds that how Docker was running without installation, because all the pre-defined tools like Docker, like node versions, node package managers, Java, and everything that is required to run that specific pipeline are pre-installed on these runners. So these runners can have a huge benefit while we have to quickly test or deploy our code. So we can use these GitHub hosted runners. And now you can see other runners. We can have Windows latest runner as well, and other types of runners. Now you can see Ubuntu latest is also used here, and the actions is also checkout version 4. So we have other runners that can be used in our CI/CD pipeline, and these are actually the standard GitHub hosted runners for public repositories. And you can see the workflow label. All these workflows can be used in our workflows. Now we used Ubuntu latest. Now let us use this Ubuntu 24.04, and let's see if our CI/CD pipeline runs or not. Now let's change it. That would be something interesting. I would use this as my GitHub Actions runner. I will use this and I will commit the changes and leave everything the same. Let's see if our pipeline runs. And this is actually the actions. And now since there has been a push in the main branch, you can see our pipeline has run without any issues. Now let's see if we have the Docker images here as well. So we don't have any other Docker images. We have only one, this image that was created by our Docker build command. Now we can see the version, the operating system, and it is 24.04. So you can see we can run multiple other self-hosted runners using these workflow labels. So if you have a .NET application, you can use Windows latest runner. If your application, or if you want to have Mac OS, then you can use these workflow labels, Mac OS 12, 13, or Mac OS latest. So that is actually a gift from GitHub Actions, and we can use these runners for free. And for students like you and DevOps learner like you and me, I'm also a learner, we can use these self-hosted runners for free. For every time we can create our pipelines, and we can use these workflow labels, and our pipelines will run accordingly. So you must read out this GitHub hosted runners. So you saw that how we built our pipeline using this simple workflow. You saw we used different GitHub Actions hosted runner. These are GitHub hosted runner. Now in the next lecture, we are going to configure our own self-hosted runner, and we will run 2 different pipelines in that lecture. So that was actually an overview of today's GitHub Actions CI/CD. And I hope that you will try it on your GitHub account. You just need to have a GitHub account, and after that just create a repository. I have created one new repository and created this new file, Docker file, with one instruction from BusyBox, and then we used this workflow that is for Docker image building. This workflow builds the Docker image. Now we will push this image to our Docker Hub repository. We will also use the Docker Hub secrets, how we can use this Docker Hub secrets, and we will also deploy this Docker image, our Docker image, on our deployment server. So that would create a complete CI/CD pipeline. So for now, you have the idea of GitHub hosted runners. You have the idea, the basics of a CI/CD YAML of GitHub Actions, and you have how a pipeline runs, and you can see the jobs. And we also discussed about GitHub Actions checkout version 4. Similarly, we will have the SSH action, we will have the Docker login action, and that is why GitHub Actions is known as GitHub Actions. So I hope that you will like this lecture. That was actually the very beginning of GitHub Actions, and I will see you in the next lecture with more pipelines and with our self-hosted runner configuration. Make sure you subscribe my channel. I will see you in the next video. Have a good one. Hey guys, I hope you're doing great today. Guys, in the previous lecture, we started working with GitHub Actions and we created a very basic CI/CD pipeline. And today we are going to discuss about the self-hosted runner, and we are going to add some more stuff in our CI/CD pipeline. So in the previous lecture, we were running our CI/CD pipeline on GitHub runners, and now we are going to configure our own self-hosted runner, and we are going to modify our pipeline so that we can push our Docker images to the Docker Hub, and then we can deploy those images on our dev or deployment server. So make sure that you subscribe my channel. We are going to discuss more about CI/CD pipelines on Google Cloud Platform as well. So let's get started, and we will configure our self-hosted runner in this lecture. So you can see I have this repository and I have this pipeline here, and the code is on the main branch. Okay, now we can see that this job is running on DevOps Molvi runner. So whether we have DevOps Molvi, this is actually a self-hosted runner on GitHub. So how we can configure a self-hosted runner? We can go to the settings of the repository, and then we can see actions here and runners. Okay, in settings we can go to actions and runner, and it is saying that there are no runners configured for this repository. So we will quickly add a self-hosted runner. And for Linux, since I have the Linux VM, and guys, the steps are pretty straightforward. You just need to copy the commands and run on your VM. So I will copy my first command, which will create a folder actions runner on my VM. This is my VM on Google Cloud Platform. So this would create the first directory of actions runner. Now I will run this command, and it will download the latest runner package. You can see each command is explained simply, and now we will run this command and it will download the runner package, and after that validate the hash. And this is an optional step, but let's run it and it will not take much time. Okay, now extract the installer. We are going to extract, this is tar archive, since we downloaded this tar archive from the runner package, and the runner package is in a tar archive, so we will extract it and I will simply run. So these are just simple commands that are given by the GitHub Actions, and each repository has these commands to configure a self-hosted runner. You just need to copy. So I have copied this command here, and now my runner has been extracted. Now we will have to configure our self-hosted runner. Okay, and the configuration steps are a bit different. You can see the create the runner and start the configuration experience. So first we will configure our runner, and then we will start the runner so that it starts listening to the jobs. And I will now use this command, and we are going to configure our runner. Now you can see it is saying connected to GitHub runner registration. Okay, runner registration. Now you can see we cannot see any runners here. If I refresh it, there are no runners configured. But when we configure a runner, we will see a runner that is ready to listen the jobs. And I will just enter the default. There are no changes, and I will name as DevOps Molvi the name of the runner, and settings have been saved. Okay, now we are going to run this runner so that it starts listening to our jobs, and the command is .run.sh. Okay, and our runner will be ready to listen for the jobs. Now you can see it is connected to GitHub and it is ready for listening for the jobs. Now I will refresh this page and we can see our runner configured here on GitHub. And you can see it is VM1 and it is idle, and now we are going to use this self-hosted runner so that it listens our jobs, and this would be the name of my runner. I have given the name as DevOps Molvi. And first of all, let's see if our runner listens for the jobs, and I will commit the changes and see if it is running and listening for the jobs or not. Now you can see it is running job build, and we must see the actions now, and it is running on our self-hosted runner. So DevOps Molvi.yaml was updated, and now we must see our pipeline as working. Okay, now you can see that all the steps of the pipeline have been successfully executed, and we must have now our application deployed on our dev VM. So let's break the steps, all the steps one by one, to know what we have done in this pipeline. And this is actually a sample node application, and in this node application we are going to build a Docker image, we are going to containerize our node application, and we are going to deploy it on a dev server. So we have a separate VM for our runner, a VM for our self-hosted runner, and we have a VM for our development. Let's say it is a development environment, so we have a separate VM for that as well. And you can see I have configured both VMs on Google Cloud Platform using Compute Engine. So this VM is dedicated for our self-hosted runner, and this is our, let's say, development VM dev environment. Similarly, we can have multiple VMs and we can use a single pipeline to deploy our application on multiple environments at one time. It is possible, and we can configure the SSH authentication using SSH keys so that our self-hosted runner should communicate with our dev, QA, or prod environments. So for now, for this lab session, I have this development VM, dev VM, and I can access it from here, SSH, and we can log in into the VM and authorize. Now you can see this is my dev environment, and I have Docker running on this server. Okay, so when we are going to push any changes on our main branch, the developer has made some changes and he has pushed those changes into the main branch. Then this is the environment of image version. Okay, every time if our pipeline runs, each Docker image will get a new tag with github.run number. Okay, now if I log into hub.docker.com, and we will see our Docker images have been updated with our GitHub run numbers. Now you can see the Docker image job here, and we would be able to see the run number, and you can see naming to docker.io web images 23. So this is actually, I have been practicing a lot on this pipeline for you for the demonstration. So you can see this is our 23, and now if I run the pipeline again, so this git run number would change and the next image would be 24. And each time our okay each time our GitHub run number would change according to the pipeline run number. And you would see we have all these images here with their run numbers updated. Now, just 5 minutes ago, we have this run number. And now we will run the pipeline again and we will get the new tag as 24. Okay, so that would be our full repository image. Now we can pull this image anywhere on any VM with Docker installed as docker pull DevOps Molvi web images, and the tag would be 23. Okay, so that's how the GitHub runner, this is actually an, you can see, an environment variable, and it will be updated as long as the pipeline runs every time, and we will have a new image tag each time the pipeline will run. So after that, you can see we are running on our self-hosted runner, and we are using this action we have discussed, GitHub Actions checkout, in our previous lecture. You can watch it to have your concepts clear. And after that, now we are building the Docker image. Okay, in this step, you can see this is a normal Docker build command to build the image with this tag. And now we are using this environment variable here and image version. Okay, now we can use this environment variable everywhere in our pipeline, and it and the value would be updated according to the GitHub run number. I hope that now you have understood why we are using the environment variable. It is to avoid hard-coded tags. Okay, we will get our Docker image tags automatically for each pipeline number, for each pipeline trigger. So in order to avoid hard-coded tags, we can use this environment variable, and it will update the image tag every time, like I have shown you here. You can see the image tags are updated whenever the pipeline runs. After that, now this is also one of the key steps to log into Docker Hub using the secrets. Now, where can we add the secrets? So in order to add the secrets, we can go to settings, and this is actually a safe approach. We should not use our secrets in our pipelines as a plain text. So we can add our secrets here in settings, secrets and variables. Okay, in settings, just like we added runner here under actions, in settings, the repository settings, you can go to secrets and variables, and then you can run, you can click on actions. You would be able to see that I have already added a couple of secrets here. Now this is Docker pass, and this is Docker username of my Docker Hub, and this is the password of my hub.docker.com registry. So I can add those secrets in secrets and variables, and I will use those secrets here with Docker login action. Okay, the Docker login action is a GitHub action that is used to log in into hub.docker.com using the username and password. Now, where the username and password are saved, we have saved them in our GitHub Actions secrets. So we can add as many as secrets as we want for a single repository. Just you have to use this, like I'm adding DevOps Molvi, or this is my Docker user abc.abc, and similarly I can add the password as docker underscore pass. So this is actually, you have to make sure that you are using all caps lock capital letters, and that's how you can add your password as well and add the secrets. So those secrets are used, we can use them anywhere in our pipelines. So I hope that now you should add secrets of your ECR if it is Amazon Elastic Container Registry or hub.docker.com. Now, after that, we would be able to push our Docker images to our Docker Hub registry. Okay, now we are going to set up our pipeline that every time our pipeline builds the code, we get a fresh tag of our pipeline of our Docker image, and that latest tag is pushed to our hub.docker.com registry. I've shown you multiple times. You can see we are having updated tags each time our pipeline runs. So that is actually the purpose of the pipeline, that every time we build the code, we get the updated artifact or we get the updated Docker image. So every time our pipeline runs, it will push the image using these secrets that we have placed in our secrets of our repository under settings, and we will have the updated tag every time. And now we are going to deploy that Docker image using the pipeline. So I will share the repository link. I will share the pipeline with you guys, so you don't have to worry if you're confused about any step. You can go to the pipeline and you can ask me in the comments, and I will answer each question that you will ask. So you have to understand the steps here, and these are straightforward steps, just like we authenticate from one server to another, and we can deploy one thing from one VM to another VM. So that's what actually happening here. This is our dev server. Okay, you can see this, I have copied, and this is our second VM. Okay, this is our dev server, and I am using SSH keys to access this VM. Okay, for instance, if I run it from my runner, it will log in. Let's see. Okay, if I now, you can also see that job build was completed successfully. So if I run from my runner, then you can see that I would be sorry SSH. You can see I can log in from my runner without password. This is actually SSH key authentication, and you must know how we can authenticate one VM with another using SSH keys. I have a complete lecture on it, and I will share the URL of that video tutorial. So you must know how we can authenticate one VM to another with SSH keys. So now their communication is easy. I can talk to my development server or QA or prod using SSH keys. So you can see I can SSH, I can access from my self-hosted runner to my development server, dev server using SSH keys. So I will exit, and now I will run my runner again. Okay, so back to the topic, and now you can see I have been using SSH keys to access the deployment server or dev server. So my environment is dev, and now you have to understand these commands. So this command will log in on our dev server. This command would be used to log in on our dev server so that we can log in with Docker login, just like normally we can use. For instance, I can use Docker login command, Docker login, and it will ask for the username and password, and I would be able to log in using username and password using the Docker login command. And so that the same command is used in that way that we are using Docker login. The username would be from my secrets. Here is my username, and you can see this is my user, Docker user, and the command will use the Docker user from here and the Docker password from here of my hub.docker.com, and that password is actually passed to this command, to the Docker login command, and it will use like Docker login my user, which is DevOps Molvi, and the password. What is the purpose of this? We can simply run Docker login and we can simply paste the Docker username and password, but that would be in plain text. And in order to make it more secure, I have used this command. You can search this command on Google. You would be able to find it easily, but you have to understand why we use this command. The use of this command is to make our Docker secrets more secure. We do not want to have our Docker username and password to be shown in the plain text. Okay. For instance, now SSH with the deployment server, you can see I can SSH, and here now you can see login is succeeded using the Docker username and password. So if I am not using this command, we would be able to see the username and password shown here in our pipeline. So in order to hide our username and password of our Docker Hub registry, we have used this command, and it is used to log in to the Docker Hub. And after that, once I am logged in, I will pull the updated image every time, and simply I will use the Docker run command to run this image. Okay, I hope that now these steps are clear. So every time the pipeline run, it will pull the updated tag with the Docker pull command, and you can see we have already logged in using this command. So after that, it should run the application using the Docker run command, and our application would run on port 8080. So now if I log into my deployment VM, which is dev VM, now you can see that we would have a couple of images that have been pulled every time the pipeline runs. And we have our application deployed in the form of container, and you can see it has been deployed on port 8080. That tag was used. This is our Docker image that was pulled from hub.docker.com, and application is now running on port 8080. Let's see. You can see it is running on this port on this IP address. So there are a lot of other things that we need to address, because sometimes it can be a port issue. You have to make sure that your runner can communicate, or it can be accessed. Your dev VM can be accessed from your runner. So there are a lot of troubleshooting issues while we are running CICD pipeline, because sometimes we cannot access our dev or QA VMs. So in order to make this pipeline, I have created instances. We have to make our environment that is actually a complete dev environment. You can see our VMs were running on our Google Cloud platform, and I can and those VMs were in the same virtual private network. So I have allowed this firewall rule to open traffic on port 8080. And now if I repeat the pipeline again, you can see we have this main branch and changes are being pushed to this branch, and we have this environment variable which updates our image tag each time the pipeline runs. This is one of the beautiful things of GitHub Actions. We have these environment variables in Jenkins as well, which is build number. So here it is git run number. And now we are running our jobs on our self-hosted runner. You saw we created one for us using a VM, Ubuntu VM, and we can go to the repository settings here. Sorry. We can go to the repository settings, and under actions we can create runners as much as we want. And also once our runner is running, we can use the runner name here in our pipeline. And in our first lecture, you saw that for GitHub hosted runner we were using Ubuntu latest. We discussed about the different names of our runners that are offered by GitHub Actions. So this is our self-hosted runner. So we have used our self-hosted runner name, GitHub Actions checkout, to check our code and changes in our code, build the Docker image with updated tag. This is the Docker build command, and that's how we are tagging. It is using this Docker file. Okay, this is the Docker file. By the way, I didn't show you, I'm sorry for that. This is our Docker file that is used to build a custom Docker image for our node application. And everything we have, these are the files of our node application, and I will share the link. This is, by the way, a public repository, so you can find it on my account. I will share the link as well. From here we are logging in our hub.docker.com registry using the username and password that are saved under secrets. Okay, here settings, and from here we can save our secrets so that it will make our secure pipeline. Just like we use Ansible Vault for securing our secrets, or HashiCorp Vault for securing our Terraform secrets, we can use GitHub secrets known as repository secrets to hide, to secure our username and passwords. We can even use SSH keys, SSH password of our VMs as well. So after that, our images are pushed using these secrets to our Docker Hub. You saw we have our image tag updated each time our pipeline runs. Okay, these are the tags. So the benefit of CI/CD pipeline is every time we get a fresh and reviewed updated code in the form of Docker image, and then we can run this image into a container to check whether our changes have been replicated as well. So every time the pipeline runs, it will pull the updated image. Okay, now you can see here updated image is pulled every time. I have shown you here. We have the tags. Every time pipeline runs, we get a new tag. Okay, I'm keeping a couple of tags on my VM since it is just a 10 GB VM. So there are a couple of tags, rest are removed accordingly. So you can see this is the command which is used to SSH from our self-hosted runner to our dev or QA VM. So make sure that you create a key pair and you can authenticate your self-hosted runner, and you can easily access your dev or QA VMs. And after that, we logged in using this command, which is a secure command to protect our username and password, because it uses password stdin. This is actually the term that hides the passwords. It encrypts the passwords, and we do not use our passwords in plain form. And after that, once we are logged in on our dev VM, we can pull the updated tag and we can use this docker run command to run our image into a container. So you can see this was our VM, and we have deployed our application using this pipeline. Now let us discuss another pipeline, and I will also share the link of this main.yaml. This is actually lamp, just for playing around with GitHub Actions. You can just have some fun running a lamp server, Linux, Nginx, MySQL, and PHP. Just like we normally install lamp on a Linux VM, we install MySQL, we install PHP, PHPMyAdmin, just a piece of cake to install. We can use Docker Compose and we can use CICD pipeline to install and to set up a LAMP server using our CICD GitHub Actions. And you can see we have this Docker Compose.yaml file. This is actually tested, and I have played a lot with this, and you can see this is my full Docker Compose.yaml file, and this is our main.yaml file, which uses GitHub Actions pipeline, small simple pipeline in which we just run, build, and push the images to hub.docker.com, and then we can use Docker Compose up -d command to run our all Docker images using the Docker Compose. So you can see I have been working on this workflow, and we have been running CI/CD pipeline just for our node application, which is a test application, and we can use this CI/CD pipeline to deploy a containerized node application. And these are the steps in which our code is checked out, the image is built, we log into Docker Hub, we push the updated image, and then we authenticate with our deployment server. If you want to use this pipeline, you have to update your secrets, you have to update your dev VM IP address and SSH keys. And after that, once our image is deployed into container and our container runs, then our pipeline is completed. So that was actually a simple pipeline as well. We are going to cover more complex pipelines in the future, and also we are going to discuss CI/CD pipelines on Google Cloud Platform. For now, I think we should postpone using Jenkins and we cover more advanced tools like GitHub Actions, and we are going to configure and run CI/CD pipelines on Google Cloud Platform as well. So that's it, guys, for today's lecture. I hope that you have liked this lab, and I will share the repository link so that you can set up your own CI/CD pipeline, and you can have your VM, local VM as well, to configure a self-hosted runner. But since we are gradually moving towards cloud platforms, after all, we have to work on cloud platforms like GCP, AWS, and Azure. So that's why I have now thought that we should shift deploying and working on actual cloud platforms and cloud environments. In case of any issues, please make sure that you ask any questions in the comments, and I will try my best to respond as soon as possible. Make sure that you subscribe my channel, like the video and share on LinkedIn and other social platforms. I will watch you in the next lecture. Have a good one. Take care and bye. Hey guys, I hope you're doing great today. Well guys, our CICD journey have been great so far because we have covered a lot of stuff that is required for a DevOps engineer to know about CICD. First of all, we discussed about what is CICD and what is the difference between CI, CD, and in CD we also further discussed the difference between continuous deployment and continuous delivery. CI, which stands for continuous integration, is related with the code building, compiling, and testing part. So we have a pipeline that is divided into two major portions, or we can say that two major parts. One part of the pipeline is related with code building and testing. The second part is actually the code deployment. So that is actually CI. CI is code building, code testing, code compilation. Any changes happening in the code are they come under the umbrella of CI, continuous integration. And when we have to deploy that code to our deployment environment, to our deployment VM, to our deployment environment on the cloud like AWS or Azure or GCP, then this part is CD, which is continuous deployment or continuous delivery. In addition to that, we also discussed about the difference, slight difference, but it can be huge for large projects, which is the difference between CD, I mean to say continuous deployment versus continuous delivery. Continuous deployment is fully automatic, and in continuous delivery, a little human intervention. I mean, my intervention or your mouse click would be required to finally deploy the code. So that was a quick revision. You can see that I have this CICD playlist that has been created for you guys, and we discovered what is CICD? CICD tutorial for beginners. We also discussed about CICD pipeline in detail, every step, like code building, testing, and also integration test, unit test, and code deployment. And after that, we also talked about 10 best CICD tools and 40 CICD important interview questions and answers. And after that, on LinkedIn, I asked about the CICD tool that we should cover in our CICD playlist. And one of my fellows and other people also suggested that we should go with GitHub Actions. And this is actually a two-part that is actually lab session, in which in the first session we discussed about the basics of GitHub Actions, the terms that are used in a GitHub Actions CI/CD pipeline. And in the next part, we also expanded our pipeline, and also we discussed about GitHub hosted runners, and we also created a self-hosted GitHub runner. We had our VM on the cloud platform like Google Cloud Platform, and we configured a self-hosted runner on GCP. And after that, we deployed the pipeline and we deployed our node application on a dev VM, and that was actually a dev environment. So as a DevOps engineer who is beginning his or her career in DevOps, I hope that that would be enough to know about CI/CD in the early phase. So we will have, definitely we will have a lot of other CI/CD projects coming on, but for now we are going to discuss the basics of GitLab CI, and then in our DevOps roadmap 2024 we are proceeding with Terraform in the upcoming lectures, because we have to wind up all these tools so that we have a full-fledged DevOps journey in which we began with Linux. We learned about Linux. We covered 75 plus commands on Linux, and then Docker, and then Git. We had courses created on this channel. So for subscribers like you guys, first of all, I thank you a lot for supporting me so far in this journey. So you saw that we have created courses, we are working as a team together, and there would be a small course of CICD as well, and then we are going to proceed with Terraform and Kubernetes as well. So other CIC projects would be coming on this channel, and especially in this CICD playlist which I have created. And today we are going to discuss the basics of GitLab CI. So first of all, you must know that GitLab and GitHub both work on Git, and they are actually, we have code on the cloud. Okay, we would have our repositories, we would have our code base on the cloud like GitHub. There is a minor difference, I would say, that in between GitHub and GitLab. So if you know GitHub Actions CI pipelines, I'm pretty sure that you can cover GitLab CI real quick, because the terminologies, the secrets, the runners, everything is almost aligned, but there would be a lot of difference between GitHub Actions and GitLab CI, because both are different platforms. But the terms for me or for you as a DevOps engineers, those terms are really, really same, that we can understand real quick. We have runners, self-hosted runner known as GitHub hosted runner, and here we will have GitLab hosted runner. We can configure our self-hosted runner on GitHub Actions. We can also configure self-hosted runner on GitLab. So the pipelines are almost the same. The phases are just like build, test, and deploy, and the pipelines are also in YAML format. So if you know GitHub Actions, I'm pretty sure that you can learn GitLab CI real quick. So in this lecture, which would be an introduction only of GitLab CI, because most of the people say that, the DevOps experts say that in the beginning you must at least know one CI/CD tool you have a strong grip on. So it is just an introduction. If you like GitLab CI, the purpose of creating this video is that if you like GitLab CI, you must create a free account on GitLab. It is a free account, and you can test, you can run free CI/CD pipelines on the available GitLab hosted runners, just to interact with how GitLab CI works. So let's get started and know what we have in GitLab CI. So first of all, you can create a new project. You can see I have a couple of projects. These are just dummy, a testing environment that I have created with my personal email. And you can see there are a couple of projects I have that are just to test and deploy how things work on GitLab CI. So in order to create a new project, you can click on this plus sign and you can create a new project or repository. The project means the repository, a code repository. You can create new group and new snippet, but for now we don't have to learn everything in this lecture. We are going to discuss the things or the points that are related with CI/CD only. We would be going to CI/CD specific, and we have to limit ourselves to CI/CD because it may become overwhelming for some of you guys, that there are a lot of things. What should I learn? No, you should. I think, in my opinion, we should limit ourselves to CI/CD only, and we will discuss only the things that are related with CI/CD. So in GitLab CI/CD, we have repositories. In GitLab, we can also create branches the main branch, the feature branch, everything just like works as GitHub Actions. And this is actually a new project. That's how we can create a new project. And you can see create a blank project from template and import project. That is also one of the beautiful things of GitLab CI, that we can also import projects from TeamCity, from CircleCI, from GitHub Actions. And for instance, I will show you that this is the project Sharks node, and I have the same project on GitHub as well. And I imported this project from GitHub. So the import is simple and it really works like a charm. You have to just provide the username, password, so that you can import everything that you have on GitHub or CircleCI or TeamCity, the other CI/CD tools, and you will have that project on GitLab. So if you have your code on GitHub, suppose you have your testing, you have your pipelines, and you just want to play with GitLab CI. All right, man, let's now explore GitLab CI. So that is actually the beautiful thing, that you can also import project from GitHub Actions, GitHub or TeamCity. Or so we can create a new blank project, we can create from template, and we can also import the project. For instance, if I click on the import project, you can see the history that I have imported this project from GitHub. So I have this repository on GitHub as well. You can see here, this is my Sharks node repository on GitHub. So I imported it from GitHub to GitLab. So you can use the import option, or we will create a new blank project just for CICD class. I will create a blank project and I will see GitHub tutorial lab, and this would be the project URL, and this would be my project slug. I mean, that would be a complete URL of my project. And this is my visibility. Either I want to have this private or public, so I will make it public. And just like we have readme in GitHub, we have this in GitLab as well. So I will just create this project, and now I have this project created, and you can see I have one commit, one main branch. Okay, we can also create other branches as well. So we have this one main branch and readme, which is the default readme, and to get started with GitLab. So now for this project, you can see we have this build option to build our CI/CD pipelines for this project. But before that, before building our pipelines, we have to see a couple of settings of CI/CD. Just at the bottom, you can go at the bottom of your project. Okay, I will scroll down, and at the bottom there are settings. And now I will scroll further, and you can see that I have these CICD environment settings, and you will find everything regarding your CICD settings here. And expand pipelines, you can check the options here, but for now we are going to see the runners. Okay, now we have our project runners. Like you can see, I have created these runners, but now these have been stopped. So I can use the runners, instance runners of GitLab. But for using GitLab runners, I have to check this option, this so that I have to enable instance runners for this project, so that this repository should use the instance runners of GitLab. So I have these runners online. These are actually the VMs. We can also study about these runners. I will just open it in a new tab, and you can see there are a lot of information. There is a lot of information about runners and how we can use the runners. There is a tier plan in which we have premier and ultimate runners, and we can have GitLab and self-managed and GitLab dedicated runners. So you can if you want to read out, it is a good read, and you will have everything information about your runners. Okay, and after that we can also create our own GitLab hosted runner using this new project runner. I will click on it and I can add my own project runner. For instance, DevOps, Molvi, just like we had in GitHub Actions. And this is for my pipeline for CICD, and I will just click on create runner. Now I will get the commands and further instructions how I can register a runner. This is just like the same thing we had in GitHub Actions. For Linux, I will have these steps and I can execute these commands on my VM or on my uh, Google Cloud instance. So I will I will have my self-hosted runner registered with GitLab. But for this lecture, we are going to use our GitLab CI/CD runners, and for that we have to enable instance runners for this project. I will just pause this runner since it is not have been configured completely, so I will pause it. And if I don't want to have this runner, I can remove the runner as well. So if I want to remove it, that just simply click on remove runner and it will remove it, since we have not configured it completely. And for this tutorial we are going to use this the instance we are going to use the instance runners that are available from GitLab. So these are all runners. Now, other things that we can explore about CICD, about variables, we can have our variables stored here. You can see I can create the variables for let me share another project, and I have already created a couple of variables here in Sharks node repository, and in settings CICD, and we have that's how we can expand and we can have the variables in the variable part of CICD. Okay, so that's how you can create variables that would be used in our CICD pipeline. So these are a couple of settings that we must know about GitLab CICD. And now after that, we can go to the build option to see if we have any pipelines on our GitLab CICD. And we can start with a sample GitLab CI YAML file. So this is actually the pipeline on GitLab, but we have a lot of templates. Like we have the template for Docker, Django, and we have for Flutter and Go. So I have this sample pipeline, and you can see there are a couple of jobs, and we have this build job in which the stage is built, and just a simple command that will display the user login of GitLab. And we have these test jobs, and this is just to get in, just to have some interaction with GitLab CI/CD. So I will just commit the changes, and now you can see that my pipeline has been triggered, and there are actually three jobs. You can see build, test, and deploy. Okay, these are actually the three stages of a CI/CD pipeline. And now you can see the pipeline is running. I can click on this icon and I will have this beautiful uh, user interface of how my pipeline looks, how the stages of my pipeline look. Now you can see the build job has been completed, and I will just click on it to see what has happened here. And just this is just beautiful, just like we have in GitHub Actions. We have the detailed console of our all jobs that have been running on our pipeline. So you can see we have this runner here, okay, and this is actually the GitLab hosted runner. So you can see that our jobs have run and the tests have been passed, and we have used the GitLab hosted runner. This is actually the runner information. And now our jobs here as per our CI/CD pipeline. So you can see the job has been succeeded, and we have used this image Ruby 3.1, and we have pulled the Docker image, and after that the environment was prepared on this runner, and after that getting source from the Git repository. So here this is our actually the workspace, and our repository was created on here on the GitLab runner, and you can see it is saying that created fresh repository. So that's how we can use GitLab CI/CD pipeline. And if I go to the pipelines again, you can see all the stages have been cleared, and we can see the GitLab CI.yaml file here, and we can also edit using the pipeline editor. If I want to add, for instance, I want to add more jobs here, and then I can for instance, this is my job 3 and this is my job 4. So that's how I can add more jobs, and after that we can commit the changes to the main branch, and you can see the main branch has commits, and our pipeline has started and the build is now running. So we can use this button view pipeline, and we are able to see more tests have been added. And so for instance, our application has these unit tests, integration test, modules test, etc., regression tests. So that's how we can add more to our pipelines, and this is the YAML scientist, and that's how our pipeline starts building. And therefore we are using GitLab hosted runner to deploy our code to the production. So that was actually just a basic demo of how CI/CD works in GitLab, and you guys have noticed that everything is almost the same. If you know GitHub Actions CI/CD and YAML, you know well, then you can add stages, you can add tests, you can add deployments in GitLab CI/CD. So you can see we have total 6 jobs, and after each job is completed, we move, our pipeline moves toward next job, and that's how we can also click on each job to see the logs, to see the output. Now this is actually the full output of our CI/CD pipeline, and we get all the information, we get all the steps, and you can see the job was succeeded. And after that we have everything, and you can see we have this deploy prod job, and it is still running, and now it has also been completed as well. So for instance, if I go to another repository, and this is my sharks node, and we have a couple of steps here as well in the pipeline. This is my pipeline editor, and I want to show you how we can deploy node application using CI/CD in GitLab. And this is actually the version, okay, and this is the variable of my Docker image. This would be the tag. So we are using hard coded tag here, and these are actually stages. Okay, we can define stages in GitLab, and each stage is, when it is successfully completed, then we can move towards the next stage. So in the first stage, you can see we have been compiling the code and installing dependencies using package.json. And after that, you can see in this stage we have used npm install that will read package.json file, and it will start install everything including binaries, dependencies, and files that we need for our project. And after that, we have used the build docker stage, and in this stage we are building using this as our base image. This is actually the base image from GitLab CI, and I have used this command. The command is mentioned, the script actually tells us that we have some commands that we need to run. We can add as many commands as we want using this syntax, and I have used docker build command to build the image with image version as 5.0.0. We can also use GitLab variables to use dynamic releases, dynamic tags as well. But for this pipeline, I used just the hard coded environment variable. Now you can see we have pushed our docker image using the push docker stage, and in which we are using this as our base image. And also we have logged in using username and password that I have shown you that we use, we store in variables in settings, and in CICD we have everything in our CICD settings. Here we have stored the variables, expanded. You can see the variables: username, password, SSH keys, SSH password, host name, username information. We can use variables to store our secrets in GitLab CI. So after that, when we are logged in, we can use the docker push command to push our image to the Docker Hub registry. And after that, we are going to run our Docker image. These are the same steps that we did on GitHub Actions, but the syntax is a bit different. So that's what we need to learn. We need to learn the YAML syntax of GitLab, which is a bit different from GitHub Actions YAML. And now you can see we are using the same image, Docker image, and we have logged in our Docker Hub to pull the Docker image, because we are going to deploy that image. And once the image is pulled, we can use this run Docker stage. This is actually the stage in which we have deployed our application into a container. So these are actually the stages that are executed one by one, and once these are executed, our node application is deployed into a container. Now you can see we have all these steps one by one, and these have been successfully completed. We installed dependencies, the build was passed, and after that the test was also passed, and after that our container was deployed. So if I want to view the full pipeline, I can click on past, and you can see this is our pipeline, and the total time that this pipeline took, and each step was completed successfully until our container was deployed. So if I want to see what's happening in each step, I can open it, and we can see that in each job, for instance, this is our job, and that was our GitLab runner, and I created a self-hosted runner using this node image. And after that, we can see npm install was run, and once it was run successfully, our job was completed. And in the final step, we can see our application was deployed using the deploy job, and now you can see that that's how we executed the command, and after that uh, our container was successfully deployed. So that was actually, I like this the user interface. This user interface is beautiful. So you can see we are aware of each step that is executed successfully, and that was actually a basic demo of how CICD works in GitLab. And you saw that we also discussed about GitLab runners, we discussed about pipelines, jobs, pipeline editor, variables, everything that is relevant to CICD. It comes under build. Okay, so everything we want to build here is the build section, and if I want to write the code or merge request or and everything regarding repository, it is under code. So we have only discussed about the build section, and similarly we have artifacts. We can have our artifacts on GitLab, but since we are using hub.docker.com for our images or artifacts, we have been using Docker Hub for our artifacts. And here we can have our CICD full settings. This is really important that you must know about runners, artifacts, variables, and auto DevOps means that if I want to have fully automated DevOps process, then I can use this utility to automate building, testing, and deploying our application using GitLab CI. So that's it, guys, for today's lecture. Actually, I wanted to give you an overview of GitLab CI. I would recommend that you must create an account on GitLab. It is free, and you can use these pipelines that are predefined, or you can use the templates of those pipelines, and you can use GitLab runners to try GitLab CI. And also you can explore the GitLab CI/CD settings here and what we have in the build section of our repository. So GitLab CI/CD is also fantastic, but I do not want you to get overwhelmed that you must know GitHub Actions, you must know GitLab CI/CD. The purpose of creating this video is that actually both GitLab and GitHub are, in my opinion, you can disagree with that, they are easy to learn. If I know GitHub Actions, I can easily work on GitLab CI. Actually, that is the motive of my this video, so that you can have two tools on your resume of CICD. But if you want to limit yourself to GitHub Actions only, that is your choice. But the purpose of creating this video is to motivate you or to boost your confidence that you must know at least two CI/CD tools. And we have GitHub Actions, we have GitLab CI. So that was actually a very generic or very brief overview of CI/CD in GitLab. That's it for today's lecture. I hope that you really liked it, and I would appreciate your support. In the next upcoming lecture, we are going to start with Terraform, and that is actually the most super exciting thing coming on our DevOps roadmap. We are going to build infrastructure using Terraform. And guys, if you have any questions, feel free to ask me in the comments. We have covered CI/CD, we have covered CI/CD pipelines, we have covered the basics of GitHub Actions, we have created a fully automated CI/CD pipeline to deploy our containerized application. We have discussed 40 interview questions and answers of CI/CD, and that is the overview of GitLab CI/CD. So that's it for our CI. So that's it for our CI/CD section. We are now going to discuss about Terraform in our DevOps roadmap, which is, I think, fifth tool of our DevOps tools. So I'm really super excited because we are now getting closer to Kubernetes, which is one of the biggest DevOps tools that would have immense uh, learning, and I would really appreciate if you stick with me in this DevOps journey, and together we are going to learn a lot. Make sure to subscribe DevOps Molvi. I will watch you in our Terraform introductory lecture. Have a good one. Bye.